All right. How was the week? How's the week been? Please feel free to unmute to speak. How's the week? I want to hear um feedbacks because this is the fourth week, I think. So let's maybe get some feedback. How's the course been so far? Um, has it been helpful? Do you think are there areas we can make better? Maybe we'll just take some feedback before we get into the content of the day. You have your ability to unmute, so please just unmute and speak. Hello.
Hello?
Yeah, please go ahead.
Okay, this is Manuel Christopher. Okay. I just wanted to point out the issue that happened last time where the virtual event, the link to the virtual event, let's say
Come again.
when it's 9, the link to the virtual event, when
The
it's
link.
9 p.m., yes, when it's 9 p.m., we can't log back in. That's how we missed the last quiz because we couldn't log back into the meeting and the quiz was going on. And we didn't know what was going on. That's how we couldn't go back and the quiz passed. Like I missed the quiz, and quite a number of us indicated that on the Slack channel. So I don't know if there's a way whereby they can add 15 minutes after the 9 to the link so that we can, for example, in the cases of inequality, somebody can click on the link and still log back into the meeting. Thank you.
Uh, all right. All right. Noted. Okay. Yeah. Noted. You're actually very right. The link or the schedule for the meeting is from 7 to 9. So it makes sense that if we, I guess maybe the challenge was that we went beyond 9 o'clock, and then and of course if it's after 9, the you can't join again because on the platform the meeting is over. You get. So I think two things is either we ensure that we finish before 9, so all of that can be sorted, would not even occur at all. That's one solution. Another solution might be that maybe we the edit the event to extend to like 9:30 so that it covers for any spillover. So yeah, noted. That's taken. We can't do that for this meeting already because this has already started. But I'll see how we can edit it so that from the next meeting that doesn't occur again. So maybe what we can do for this meeting is to ensure that whatever the case is, we're able to start the quiz maybe 20 minutes before 9 so that there are no issues like that. All right. Thank you. Noted. Noted. All right. Any other person want to go? Joel Joy, please go ahead. Sorry, Joy Joy, can you go ahead, please? I can't hear you. Hello. Okay, if I can't hear Joy Joy, but maybe somebody else can go. All right, is there anybody else? Okay. Um, Joy, do you want to try again? Because we can't hear you, or is it just me? Oh, sorry, didn't know I was muted. I said maybe we'll go to another person if Joy can't speak. Okay. All right. Since nobody else wants to speak, I guess we'll just have to go into it. All right, Samson, please go ahead.
Hello, Daniel. Good evening.
Hi, Samson.
So, to be honest, I didn't get the question that you were asking people to speak about. So, could you maybe take it
Okay,
again and
I was
have
asking
something?
for feedback. So this is week four.
Yes.
This is week four. So feedback on the course so far. Is it making sense?
Okay.
What are some of the highlights? What are some of the um, downlights
Mhm.
or low lights?
Yeah, indeed. Okay, I think I understand what you mean now.
Yes,
Okay, that's as it regards to these sessions that we always have, right?
everything, everything,
Oh,
everything.
okay, everything. Okay. Well, for me, it has been awesome. For me, it has been awesome because I know it's difficult to read the intention, but I can feel the intention of the community or of the organizer. I can feel the support that they're always trying to give or trying to answer questions in a way that we are able to understand. So I can feel the good intentions. The vibe is great. I remember one of the recordings I was listening to, and I think it was you. I think you were in the car or something, and then but then you still made the effort to make sure that you delivered the session. And I really felt that okay, this is a really supportive community because you don't want us to miss out on the activity for that day. In terms of content too as well, because I know a little bit about some of containerization. I noticed that the curriculum that you guys and the things that you're focusing on, from even how you started, it builds up on top of each other in a way that one can keep going. And then in terms of freebies, the course also, I was lucky to get the course. I've started it, and the course is awesome too as well. It's awesome, awesome, awesome. So for me, it has been a great experience. It has been a great experience. So when we say maybe areas for improvement, I can't say yet, but maybe after another 4 weeks. So, but for me, it has been a great experience.
Okay. All right. Thank you, Samson.
Yeah.
The course the James Spearing course that you were talking about,
Yes.
have you, how far have you gone in it? Have you gotten to where we are currently in the
Okay.
life classes?
Right now, I am at, let me say, I'm 25%. I'm on container networking services and volumes.
Okay. Okay. All right.
Yeah. Is that where we are?
No, we're already on Kubernetes, and last week we did
Okay.
um, fundamentals of Kubernetes. This week we're going a bit. We're still doing Kubernetes, but just going looking at some other things as well in Kubernetes.
Okay. I guess I have some catching up to do.
All right, that's fine.
Thank
All
you.
right, well done. Is this the
Yep.
first time you're attending the live class?
No, no, no. I've attended, I think, about two of them. I
Okay.
missed one. I know I missed last weekend.
All right. All right. Cool.
Mm, mm.
All right. Thank you.
Yep.
Thank you very much.
All right
Okay.
then.
Is there any other person that wants to speak? Okay. People seem to be shy today, so maybe we will. Uh, okay. E Nedosa. Please go ahead.
Okay, good evening, Daniel. Good evening, everyone.
Hi.
Um, so for me, I would like to say thank you for the course and for these sessions we've been having. They've really been helpful for me, and I think that I would say about the course. I think it's a lot centered towards writing the exams, and if you have any other recommendations that would be more suitable for like visual learners for hands-on kind of practice, a little more hands-on practice that will get us more comfortable with everything like DevOps and Kubernetes and everything that has to do with like DevOps. That would be really helpful. But as far as everything is like the course is going really well, and the sessions here have been also very helpful. So thank you.
All right. Thank you. Did you get the course? Did you get the?
Yes, I did.
Okay. Have you started?
Yes, I have. I haven't gone very far, but I have started and it's
Okay. So
going.
by the time you get to the Kubernetes sections, right? You will There will be the labs there, right? That you can actually do hands-on for every single topic, every single lesson. There is hands-on. There are hands-on exercises. There are hands-on exercises to do. So you will have a you will have a lot of hands-on when you get to the Kubernetes aspect. But the KCNA is MCQ. It's multiple choice question exam, right? And
Yes,
uh, and so yes, it's important for you to get a lot of hands-on, right? But since the focus of this particular boot camp is to prepare you
for
for
the exam, I understand. I understand that fully. As far as that preparation is going, that's going really well.
awesome. Okay,
Thank you.
you're welcome. All right, so just to just to read the room, is there anyone on this call that doesn't have access to the uh, course that was given? I just want to know. Is there anyone on this call that doesn't have access to the course that was given? If you can just notify, just let me know. Destiny Erabo Erabo Ehabo. Sorry, sorry, Destiny. Okay, you are saying yes. That is, you didn't get the course, right? Hello, Richard Chuku. You didn't get the course. Sorry, Richard. I know you've been around. I know. So just a minute.
Me.
Why do you know why you didn't get it? Why didn't you?
Oh, okay. So I think I just joined my first I joined the first one that then it have already been distributed, right? So I missed the first two section, first two classes.
Okay, okay. Because I thought, okay, maybe I thought I've been seeing your DP look very familiar. So I thought,
Yeah,
you were on the. All right, that's
yeah.
fine.
Hello, Daniel.
Yeah, go ahead, please.
Yeah, you're asking. I didn't get the course actually. I was not part of the top 30 names, so unfortunately,
Okay, you
it's
didn't.
and it's
You
on
didn't
me.
participate. You didn't
Me
participate
actually.
in the quizzes.
Yeah, it's on me actually. I didn't participate in the quiz. I was really engaged, but
Okay. All right, no
I'm
problem.
working to it.
All right, no problem. So I'm just trying to know how many people on the call did not get the course. So I just want to have an idea. So one, two, three, four, For Mohammed, you got the course. I can see your name on the list. Got the course and already studied from it. So 4 people out of 24 people. Well, okay, let's say 23 plus myself. Okay. All right, no problem. I just wanted to know so that because we can actually have a lot to. I don't know how I missed up a lot of things. If I had thought through, if it had occurred to me when we were doing the design for how to schedule the course, we would have you know still pushed ourselves some more last week, because this week is like there's just so much to talk about or to attend to. Okay, but however, we will just dive deep into it. Let me share my screen. um Sorry, I hope the noise around is not disturbing the. Okay. All right. All right. You can see my screen, yes?
Yeah, we can see Kubernetes presentation.
Awesome. Awesome. Thank you. So, if you remember, from last week, I think maybe it's something I need to work on. But when it comes to presentations, I just rather just uh, go through outlines, we discuss it, make it interactive. Slides for me are just really boring. I'm not saying it's a good thing, but it's just how it's just how I roll. So we'll look at the first thing we'll be looking at is what's it called now? Jobs and cron jobs in Kubernetes. Um, I guess maybe I should just do this so that we can take it. Okay. All right. So we have quite a lot to deal with today. All right. So does anybody want to just quickly unmute to I just want to read the room to know who really understands when they hear jobs and cron jobs. What comes to your mind? What do you know what it is?
In the context of Kubernetes, right?
Any context, any what just
Okay.
what comes to your mind first when you.
Okay. When I hear a cron job, I know that that's something that you want to automatically run at a certain point, or it's a job that you don't want to have to be doing manually and you want it to repeat itself. So I
Awesome.
know that that's what a cron job is.
Okay. Awesome. Yeah. So it's the same concept, right? In Kubernetes as well. So we had talked about um, you know pods last week, right? And we said these are the pods are the units of compute within Kubernetes. All right. Before previously we had talked about containers. All right. But by the time we got into Kubernetes, we saw that everything that we do, essentially we're managing pods, essentially. All right. So that those are the computes. That's the actual compute that gets deployed. Now, inside that pod is where you now put the containers that you're running, all right, the actual applications, and all of that inside the pod. But as long as Kubernetes is concerned, right, the end guy, the guy that gets deployed in the end, that does the work, is the pod. That's the smallest unit of compute. So um, a job, right, is a supervisor essentially, right, for a pod. All right. So you want to send an email. all right, as a response to something. So and you have maybe an application that sends emails. So you containerize it, and then it's there. Maybe you create an image for it and all of that. But you don't need that. You don't need that application to be running consistently or constantly. Just as an example, you don't need it to be running, consistently. But there are times when, as a reaction to something, to an event, or however you design system, you need that job to run. You need that action to take place. Okay. So that's where a job comes in. All right. A job is that supervisor that you create to run a pod for a short-lived. Okay, God's time is saying doesn't understand. Sorry, my net breaking. Really, is my net? Can you guys hear me? I thought the network is quite good.
I can hear you. I can hear you good. Though.
Okay, some people are complaining on the chat.
I've
All
been
right.
hearing you since you've not. Doesn't even. There's not been
Okay.
any static. I can hear you clearly.
Okay. All right. Thank you. God's time. Maybe it's your network. Um, so a job, but let me just, for the sake of God's time, a job, right, is that supervisor that will react to. You can even do it manually, actually. So it's not only programmatically, but you create a job to just execute a, to start a pod, ensure that the job that needs to be done, the task that needs to be done is done, right? It completes it, and then boom, done. Do you understand? The pod is taken out. You get, like, it's like, like an assassin that just goes do a job and moves on. All right. Maybe a very bad example, but you get what I mean. It goes straight, gets the job done, and moves on with life. All right. So that's what a job is. Okay. But the idea is that he's a supervisor, and his own is to ensure that, okay, this thing is executed successfully to completion. All right. And then you are also able to track, because of jobs, right? You're also able to track the number of successful completions, right? So you can say, okay, you can always go back to check, okay, was this thing actually completed? Was this task actually completed? Um, you know, Ghost time still complaining. Ghost time, I think, is from your end. So jobs can run multiple pods in parallel. All right. So it's not just that, the job is only running one pod, but it can run multiple pods, gets them to completion, and then moves on. Now, from I don't know who was, I can't remember who it was that talked about cron job earlier. I don't know if it was Samson, but essentially what Samson talked about. All right. So cron jobs, right? If you just think about the name, think about how it sounds and everything, you see that they're quite similar. So cron jobs, even from your understanding of cron jobs generally, it's a scheduler, or is that the right word? It runs based on a schedule. So you tell it that, okay, you want it to run maybe every day at 12 midnight, or you want it to run every 5 days, or however um, you want to schedule it. Okay, you can schedule it that way. So you don't have to always do that, creating a job manually. You can now automate, with using the cron job. Now you can now automate that whole process of creating a job, getting it to execute a task, or to run some pods, and then it moves on, and then waits for the next time that time frame comes again. So an example, right, where you will use cron jobs, right, for things like backups. So for instance, maybe you are doing backups every week, or even every day, or maybe you are sending reports, weekly reports, or maybe you are doing some cleanups. Okay. Those are some of the times where you get to use cron jobs. See the way I'm talking so slow. We have a lot to to talk about today. um Now, I just also want to say something. Those of you, I think there were about 4 people who said they didn't get the course. Um, please go to you. Well, the course has already been. We already said that it was the first 30 people from the first 2 weeks that will get it. We announced it from the beginning that will get the course. So there's really nothing we can do about that anymore because it has already been given. But however, I think one thing you can do is on your desktop, on your Docker desktop, right? Download the extension, the labs extension. Okay, so you'll also be able to execute some of these things. Okay, I think that's the best. That's the best we can do right now. Um, so maybe I'll just show. Okay, you know what? Let me not go to. Let me just use the labs. Just a minute. What's going on here? Um, all right. Can you see my screen? So I guess you should be able to.
Yes.
Awesome.
Dive
So
into.
yeah, so let's just use the labs, especially for the sake of people um, who to the course. All right. So what we are going to do is um, the first thing we want to do is to create a job. All right, create a job to calculate um, pi. All right, using the. So what we are doing is, kubectl creates. I'll just use the labs. This will just make it easier actually. Use the labs to explain some of these commands. Um, create job, calculate. So the name of the. So what we're doing is that, okay, we're creating a job, okay, and we're saying the name of the job. We're giving a name, and we're using this image. Now, remember, a job is just a supervisor that runs a pod, and a pod needs a container image. Do you understand? So we're using the image, we're using a Perl image, okay, and this double dashes is to say whatever comes after this, all right, is a command that needs to run in the container. Okay, that needs to run in the container. So now this is the command that we're running in the container to say, okay, um, calculate pi, up to 2,000 digits. Okay, so that's just what this entire command is doing. Now we run this, we can see that you can see that the job has been created. Okay, and so now let's get the jobs and let's watch. So now what you can see is that um, these are jobs that have been created. Okay. Okay. You know what? Let me, because I was doing some things earlier. Let me. Oh, do I want to do that? Okay. No need. So this is the job that we just created. Calculate pi. Okay. You can see completions, one of one, or as in 1/1. So it means that we just created one job. Okay. And we created one job and one completion, you get straight, duration. How long did it take? 15 seconds. And how long ago was that? Okay, so let's take a look at that particular job again and see some more details about it. So you can see that. All right, so this job, you can see a few things. One, when it comes to parallelism is, look, so how many jobs is it running at the same time? Okay, parallelism is one, and that's the default. Completions, one, and then so you can see. So okay, let's look at the pod statuses. So like I said, the job and then the pods under it. So how many of those pods succeeded? It's only one way. So one succeeded, and we can see that. Come on. So now the containers. So which image did it use? What commands did it run? Okay. Or when you start the container, what commands does it run? You get, and then this just gives you more details about that particular job. Just to also show you, sorry, just to also show you, see that let me, you see this pod. You can see that is status completed. Okay, it has finished its job. Normally, if pod is running, it will you will see that ready 1/1. Okay, but you can see that this pod, the status is completed, it's not running. Okay, the status, if it was running, it would show. For instance, if I create a pod, if I say okay, run sample dash image equals nginx. What else? So let me do that. Get pods again. So if by the time it finished, I'm sure what's delaying it now is that it's pulling the image, okay, from Docker. But by the time you check again, you see that this one is running, but these other jobs, okay, are not. So let me just take some time to clean up this environment, because I think it might be confusing for some people. So clean up. Awesome. All right. So now we can. All right. So now you see this is a normal pod. Okay, this is a normal pod that I just created, the nginx pod, and the status is running because it's a running, there's a container inside that is running an application, and it's doing what it's supposed to do. But this one has already completed its job, and that's why you see that the status is set to completed. All right, and that's a job for you. That's what the job does. Okay, it just runs a particular task that you want it to run, and it gets the pod into a completed status. But the good thing about using jobs is that it tracks it, so you can always come back to see what the pod ran. You can always come back to see all of that, all of those details. Okay, if it was a pod that we just created to run that same command, wait, no, let me see if I can get that thing back. I'm just trying to show you the difference between. So let's say I run this. I just run a pod to do this. no, what that is run. Now, what I've done, right, is that I created this. So it's the same task. Okay, it's the same task. I created one manually as a pod. Okay. And that's what this one is. That's what it's trying to wait for. This thing will be slow a bit, but and then but this one is a job. Okay, so I can always come back to what I was trying to show. What I'm trying to show. I hope this thing doesn't delay us. Is that by the time this one finishes what is it will just go, it will just die, and that is it. You won't see it again. So there's no way to track it. All right, so is that trackability I'm trying to um uh, just express to you. Anyway, there's no need to continue with that. Okay. Let me see. Let me check if there are any questions. Can you just requested your last week access Docker Compose? How to choose between cron jobs or jobs that suit workload? Okay, so jobs now is, you can see I had to do this manually. So imagine if I have to do this same job or execute the same task uh, maybe every day. It means I have to go to the CLI or run some sort of script, all right, to just be doing it for me at a certain point in time. But creating a cron job, okay, I don't want to waste time on that. All right, so let's look at cron job. Now you can see that creating a cron job is very similar to creating a job. All right, but the only thing that now that you are adding is that, okay, of course, the name of the object, okay, the cron job, and then the schedule. You're adding a schedule. I hope you know about cron tab, um, and the cron, that whole cron syntax, how to schedule, how this thing works. There's a popular website, is it crontab.guru or something like that. Um, yeah, crontab. I think it should be crontab.guru. You will see it will just give you you can schedule your this thing there and just copy and paste whenever you need it. Okay. I don't want to, that's not what we're talking about now. It's, but it's a very simple something that you can just Google about cron, how to use the syntax for cron to schedule something. So you can see that it's very similar to the same job thing, but by the time I create this one will run every minute. All right, that's what this what is it every minute or every second? I think this particular one is for every second. Okay, and let's watch again. Let's see what
That's every minute.
every minute. All right, awesome, thanks. Yeah, so all right, so that's essentially what that's that guy is doing. Again, I don't want us to spend too much time on this. We have a lot to get into, but again, I really want especially everybody who did not get the course, please go and download the extension. All right, go and download the extension in your Docker Docker desktop. If you don't have access to Docker desktop, you can use the Docker Compose option. Okay, let's move on to the next. to the next one, unless there are questions on this one. Okay, now to the question. Exactly, QE Nedosa. Um, yeah, so that's just it. Jobs are, they're like one time um things. You do it manually, you just set it up for one time engagement. But cron jobs, you want it to be repetitive and scheduled, okay, and scheduled. So that is how you do that. Any reason to choose between job and cron job? That's what I just explained. Uh, Please also, this might be difficult to be reading through the chat. If you can just unmute and speak up. I want us to be very, very interactive.
Okay. I have one question.
Go ahead, please.
When you created the cron job, when you put in the minute, those asterisks that denotes the time the cron job should run, the schedule the cron job should run, they created, it showed cron job dot batch successfully created. What does that dot batch? What does it mean?
Okay. So now this is something we're going to get into later on. Okay, about Kubernetes API. Okay. Let me see. That's why I also want us to run, because there are 8 topics we're supposed to touch today. So after these cron jobs and jobs, we'll go into config maps and secrets. After that, we'll go into labels and selectors. Then we'll now go into Kubernetes API and access control. Then you'll better understand why it's because it's just really about the APIs, the Kubernetes API version, all right, uh, that's there. You get, but the major thing you just need to focus on right now for this particular part, is the fact that okay, the cron job has been created, okay, but this is the path according to the Kubernetes API. This is the path to the job that you just created, okay. But by the time we get into the Kubernetes API aspect, you'll better understand that. All right. Any other one? Okay, so let's move on then. I wish there was a better way to. Let me just share my entire screen, I guess. Okay, so so that's it for. I don't want us to waste too much time, but another thing. So let me just quickly talk about these aspects. So when you're talking about jobs, okay, you look at the issue of completions. So how many jobs because the job will either be successful or not successful, right? By the time it runs, okay. So of those how many of those pods need to complete the task? Or how do I put it? How many of those pods needs to be successful, okay, for the job to say yes, indeed, it is complete. For instance, um, if you are using a job to send emails, okay, and let's say you are using, let's say, 10 pods, okay, to run the for you are using 10 pods. How many of those pods need to be successful for the job to consider it a successful job? Does that make sense? um so for instance, if some of those jobs, let's say 5 of those pods fail to run, or fail for some reason or the other, okay, and but 5 succeed, will the job be termed successful or not? So it depends on the use case. It depends on what's how much assurance you need for the that the job runs, and that the job is successful. Depends. So you can say that, okay, out of 10, 8 must be successful, okay, before you know that yes, indeed, this job is successful. Okay, so if 7 are successful and 3 fail, that job will be marked as failed. Okay, the result of it will be failed. Now, on the issue of parallelism, okay, forgive me. On the issue of parallelism, this is how many pods should the job run in parallel. Sorry, just give me 1 minute, please. I need to plug my laptop. It's about to go off. Just a minute. All right, can you hear me? Okay. All right. So parallelism is how. Oh, I'm nominated. Okay, how many pods should run in parallel at the same time? Okay, so you can decide how many that is. Back off limit is how many, the number of retries, okay, before a job is marked as failed. So if a pod fails to complete, okay, should the job be retried? Okay, so now these are I mean the use cases of these things are um the use cases of these things are very wide. Okay, because I mean for different kinds of applications, different kinds of scenarios, you would find yourself, okay, when you are developing or setting up a system, because there are some jobs that you want it to try to run only once. Okay, you don't want to do a retry. All right. If you're doing some sort of maybe database transaction or something, okay, or different kinds of scenarios, okay, would require that sometimes you don't want to retry the job. All right, and there are some that it doesn't matter, you can retry several times. Okay, so you can set that there for the back off limit. Excuse me. Active deadline seconds, so that's the time limit for the job completion. Okay, you can say so that the job is not taking up your resources. Okay, you can say, okay, you want it for maybe 5 minutes or 3 minutes or whatever. Okay. TTL seconds after finish, so auto cleanup after job completion. You can set that as well. I put down some things that I wanted us to do, some hands-on, but we've already seen some of these things in the labs. They're actually there in the labs. So let's not waste too much time. If there are questions, we can take. All right, so let's move on to the next. So config maps and secrets. All right, just to quickly get get a feel of so config maps and secrets. What does anybody want to give us a hint of what it is? Tony, please go ahead. You can unmute, please.
Sorry, can you hear me?
Yeah.
So, config maps, they basically contain like external configuration of our app. So instead of us trying to build it, push the image, pull the image and everything, when edit it in that config map side. Then for the secrets, it's basically the same thing, but we cannot just put secrets inside our config map because it's not ideal. So we have to put our secrets, like our credentials and everything, in the secrets. So it's
Okay.
similar to config map, but we just store our secrets there.
Okay. All right. Yeah. Thank you very much. Tony. Okay, Sonia, Samuel, please go ahead.
Right. So I believe config maps are there are those configurations you want to pass dynamically to the pods and the containers running in it. So these configurations you want to pass might change. They might not be like constant values all the time. So you want to make sure that you can edit them before you run the pod, something like that. Then for the secrets are similar to the config maps, just that they are confidential. So you want it to be kind of hidden. So that's why you use secret because they are for confidential configurations or information. So you have to like keep them hidden.
All right, awesome. Thank you very much. Thanks to Samuel and Tony. Yeah, very, very on point. So you know how you build, yeah, I mean, you build applications and you need configurations for those applications, especially modern applications. You don't most times you don't hard code, things into your applications, especially configuration things. For example, um, you can build an application that acts in a certain way in one environment, uh, and acts in a different way in another environment. Connects to, so depending on the environment, it connects to a certain database, or different things. They're just different things to use configurations for. I mean, URLs, API keys, different things. Okay. However, um, um, there are different, there are different levels. Okay, there are some configurations that it doesn't matter. They are not sensitive data, right? It doesn't matter. So you can just put them in the config map. But then there are some things like some tokens, okay, like maybe for instance, maybe you're building an application that uses OAuth, all right, that uses Google OAuth, okay, and you need to put your client ID, your Google client ID, and your Google what's the other one called, secret key or something like that. Those are not things that you want to just put out there that gets passed into the application and anybody can see it, right? Those are things that you want to put in a secret manager, ideally, right? You want to put that you want to conceal. But however, the application should also be able to use it, but it's still concealed. So that's where config maps and secrets come in. Okay, it allows um, it allows you to pass configuration data to the application. Okay, and just like, one of the good things about that kind of system is that, I think it was Samuel that talked about it, that you don't now need to go. So for instance, if you had coded configurations into your application, right, it means that when some things need to change, you have to go into the application code to go and change it. All right, but with configuration management, you are separating configuration from code. All right, so sorry, excuse me. So let me just go through it here. So you're making configurations environment specific. You can version control your configurations. You can use meaningful naming conventions. You can keep secrets separate. You can then also, yeah. So anyways, now the idea the idea is that um, config maps, right, is that object in Kubernetes, okay, that you don't need to pass it. Like it just, what you see is what you get, essentially. Like it's not encoded, it's not encrypted. All right, but secrets are encoded, all right, with base 64. All right, but they are not encrypted. So that's one thing. That's one thing to note, that in Kubernetes the secrets are not encrypted, but they are encoded in base 64. All right, and you can use config maps and secrets, okay, as environment variables, okay, um, in in the pods. Okay, so you can pass a config map or a secret into the pod where the container and the application that you are deploying would have access to it. Okay, so you can pass it individually, you can pass all the keys in a particular config map as variables, and then you can um, yeah, so those are the major ways. And then volume mount, you can also mount it as a volume. Okay, mount an entire volume as a file, okay, in the pod. Okay, and also you can mount like specific keys as files as well. And yeah, uh yeah. So again, and then secrets. Okay, so now secrets have different types. We'll go into the hands-on, so that's but then there are generic, there's a generic secret, so which is like basic authentication stuff, Docker registry, so private registry credentials, TLS, the certificate and keepers, blah 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 blah. I just want to say something about using secrets. Like I said earlier, secrets are um, they are encoded in base 64, but they are not encrypted. So the best practice, really, if you are by the time you are using Kubernetes in production, or seriously, you actually use an external secret manager. Okay, an external secret manager. So for instance, if you're using AWS, you can use their secret manager. You can use HashiCorp, Vault. Which other ones are there? There are just so many of them. Okay, and then you can now bring those secrets into Kubernetes. All right, there's one particular project, one open source project called External Secrets Operator, that you can use to bring in secrets from an external secret manager into Kubernetes. Okay, and it will keep syncing it together. Now that's, we're not going into all of that, but it's a very beautiful project that helps to do that. So you can have that's actually the best way to handle secrets, because all those secret managers, they are encrypted, their things are more secure and all of that. Okay, than just putting your details inside Kubernetes and encoding it in base 64. That's not enough, because what it means that anybody that has access to the secret can actually decode your secret and get the keys out. And just an interesting note, Ileri, if Ileri, who is the key organizer for the CNCF Lagos, was actually part of the team, or was part of the company that built that external secrets manager. So let me farm small. At least I know somebody who knows somebody who knows somebody who did something serious. All right. So let's go to the labs now to look at how to do this hands-on. Any questions? To config maps first. Okay. So well, all right. So let's look at this command. So what are we doing here? What we are doing is kubectl create config map. This is how you create config maps. All right. Uh, create config map. So what's the name of the config map that you want to create? Now this is it. This is the name of this particular config map that we want to create. Then this is how you now pass values. So think of it as, key value pairs now. So for instance, uh, if you're building an application, for instance, and you're doing it the proper way. So so you now have configure. Let's say you have a configuration file. Most times you're going to use either JSON or YAML, all right, for your configuration. Does that make sense? And it's basically key value pairs. So that's what we're actually doing here. Well, so from literal, this is how you create. So this is how you create keys and the values. Okay. So from literal, it was to color. So this is the key. Color is the key, which is equals to red, and this is the value. So you want to create another value, you create another one again from literal key value. All right. And so basically what this is just going to do is that it's going to just create a config map. And then let's look at the config map that we just created. Excuse me. So you can see this is the config map that we just created. So what's the data? The data, that's what we just created. So the key and the value. Key value. That's just it. All right. It's as simple as that. So you can now pass this config map into a pod. All right. As environment variables. I don't know if this is making sense to anybody. Let me see if there are any questions. Okay, secrets are encoded but not encrypted. Word. Yeah, yeah. You can bring your offering now or your tithe. Um. All right. So let's move on to the next command. So let's delete that. Wow, this is why did I not do this like? Because this makes so much sense. So another way is that you can actually um, create a config map, right? From how do I put it now? You can actually create a config map, right, from a file. All right. So first of all, what we'll do is that let's create a file, all right, with the values. Okay. So think about this. Like this is a lot of times you will use it this way. Okay. So you create a file with all the values, all the configurations that you need to pass into your application. So let's do that. So what we've done now is that we're creating a file. Let me see. LS. So you can see this is the file that we just created. Config map color.properties. Okay. So what we've done is that so we are passing these values into this file. Okay. And if you do a cut on that, let me see. Cut config. So you see that's what is inside that file. All right. So a key value pairs. All right. So now let's now create the config map again, but this time around we are creating the config map from the file. So it says kubectl creates config map, same thing that we have up here, but this time around from env file. Okay, equals to config map. So we see we are passing the name of the file, okay, to this flag. All right, and you see that the config map has been created. We do let me just so you see, we've created another config map. Even we deleted that first one, okay, remember. And then you see the values from the file is what is being used in the config map here. All right, so that's another way. Let me see. Is there anything really? Okay, so let's look at how to actually use this. Okay, how to actually use this. In a pod, because that's what really matters. Okay, no need for that. So let's use it let's use it as environment variables. Okay, so what we want to do now, let's create an email. Let's create a pod that uses an image, and so we'll first of all just create this as a file, into a file. I hope anyway, by the time you are going through the course, you will see that this is a trick. This is a neat trick, especially by the time you are doing CKA or CKAD, right? It's a very neat trick to use to so that you're not writing YAML files from scratch. All right. No, most times you just want to use this trick where you use dry run, okay, to create it, and then you output it as a YAML file, okay. Do all your imperative commands, enter all the, and then you now pass it into a new YAML file, okay. So what this will do is that it will just create a YAML file for a pod. It did not create the pod, it just created the YAML file that we'll use for the pod. This is a very neat trick. Please take note of this. It will help you in the CKA and all the Kubernetes hands-on exams, but not necessarily in the KCNA. But just take note of it. I use this the entire. All right. But now let's apply the. So this is how you apply the file. No, before I do that, let me, so that you can see. We do an ls, so you can see the file that we created, the file that we dumped, the file that we created from, as a result of running this dry run. Okay, the dry run. What the dry run is that you are trying to use it to create a resource. Yeah, so you say you are creating a resource, all right, but it doesn't actually create the resource. It just simulates it, okay, and creates, um, um, gives you an output, okay, of what it would actually look like. So that's what we've done. So now what we've done is that output of what it will actually look like, we're now piping it into to create a file. All right. So that's the beauty of that neat trick there. All right. So let's run this command, which is to apply the file. Um, all right. So now we run get pods. So you see this. We see it here. It's creating the. Let's watch. Awesome. So we see the Ubuntu thing that we just created. The Ubuntu pod that we just created is running. So um, so I just wanted. So let's look at this now. You can see the environment variables in that pod. All right. Or in that container, you see that. Um, these are the default environment variables. So by the time we edit that, we are going to edit the pod, all right, to add that config map as a source for environment variables. You will see that it will now be passed here. Okay, so you're going to be using this a lot. If you are using Kubernetes, you're going to be using this, a lot. Especially if you build stuff and all. So um, so yeah, what we are trying to do here now is to edit the file that we created. Okay, that definition file for the pod. Okay, and see what we've added now. You can see that what we've added. We said env from. Okay, this is under the containers. So we have spec. All right, under spec we have containers, and then we now have env from. All right, env from is that, like get the environment variables from is a list. Okay, so the first thing is that, okay, so it means what that means that we can get environment variables from different places. All right, so config map ref, and then what's the name of the config map? The color config map that we created. Okay, so let's run that. We will apply it. If we apply this, it will fail. If we apply this, it will fail. Okay, because when you're dealing with pods and some other things, there are actually some fields that you cannot edit. Okay, so you have to delete and then recreate it. All right, so that's what we are going to do now. So we're deleting the pod and then we're recreating it. Excuse me. Sorry for the person who said that last week I was in the car and giving the lecture from there. Sorry, it's the same thing. So so it's the same thing this week. Uh, so sorry. But by next week I should be back to regular programming. Anyway, so now let's look at the logs again. All right. So can you see? Just a minute. So can you see now that a new environment variable has been added to the container? All right. See the other one, the key value, the color green. So think about this. Like this is just it's simple, but it's really powerful. All right. So it means that we can, like somebody said earlier, I think it was Tony, that said we can edit the configuration without touching the application at all. All right, and the application will respond. Sorry, excuse me. Will respond. Sorry about that. Will respond to the configuration that we've done. Okay, so let's um, okay, so yeah, so that's for that. You can go ahead and play with this in the there's some because you can edit. You can always go back, edit the config map, and it will. But you will have to, by the time you edit the config map, okay, for you to see it in the container, you will have to update the pods. Okay, so it's either you delete the pods and then recreate it, or if it's a deployment, if it's from a deployment, you just update the deployment so that new pods are created. Okay. Any questions? Okay, now let's move on to secrets. But any questions on config maps? Okay.
Hello.
Yeah, please go ahead.
So I wanted to take that how to edit a config configuration without I mean how to edit a YAML file. You said it just now, so I missed that. I don't know if you can take it again.
How to edit what? The YAML file?
Yes.
No, we just, so when it comes to, okay, you know what? So let me just go through this. So like we have this config map now. Okay. Let me see. Let's do kubectl edit config map. What's the name of that config map now? Yeah, color dash config map. Okay. Color dash config map. Okay. So let's change this. Let's change this to blue. Okay. Open that. Okay, there's going to be an issue here now because okay, my escape button is not working, so and Control C doesn't seem to be. How did this? Okay, let me see. Then nano on this thing. Nano. Okay, so there's no nano on this environment. Okay, anyway, what's let me see if I can. Yes, that's what I did. So what's actually happening is that my escape button on my keyboard is not working. So normally you do Control C to be able to get to the to come, but no. Well, Control C is not now working in this this terminal.
Okay. Maybe use Nano.
Yeah, I tried. I don't think Nano is here. So that's the.
Can you install it?
Oh, this is root, anyways. Nano. Nano. Should that work? There's even another way to actually do that, but I can't even remember where you set a, a custom escape for Vim, but I can't even remember how that, because Control C just works normally. All right, so let's try Nano. Nano app. Can't remember. Okay. Nano. Okay, map properties. Yeah. Blue. Okay. Control X, Y, enter. Okay, so let's create reconfig map. Oh boy. 8:30 already. Wow. Wow. And we've not even got this is just even the second. Oh my goodness. Oh, okay. So now so that's config map has been created now with the new color, right? So um if we do that, if we check the logs for the Ubuntu, you'll see that it's still color green. So it's not going to automatically just change, all right, because the pod is already running. All right. So what that means is that we need to, delete the pod and then also, um, um, run it again. Okay. So let's just quickly do that. All right. So now, if you now do, ideally, hands crossed, fingers crossed, ideally you would see that, yeah. So the color blue. All right. So it's taking the new config map. So think about this. Imagine if you had a web page that's maybe the background is based on an environment variable. I don't know why you do that, but let's just say that is a scenario. Okay. So it can change based on the environment variable. Just that's just an example. I think that was Emmanuel that asked that question. Does that make sense? Is that clear? Tony, when does the class end? It's supposed to end by 9 o'clock. It's supposed to end by 9 o'clock, and we have not even touched on anything. Okay, can we do this? Can I do a recording of these things and post on the YouTube and send during the week? Maybe I'll do the recording maybe by Monday and send it maybe latest Tuesday. Does that work? So that we do our quiz, and then but even that quiz now, how are we going to do it? Because a lot of these things are there. Please
Yeah,
just
that's fine by me.
unmute so that we can because I can't even believe that this is 8:30 already. So what do we think? Can we add extra 1 week for Kubernetes? Okay, that's an idea. Inedosa, please speak.
Good evening. So I was going to suggest if we could extend the class, since some of these things are part of the quiz, we could just go over them quickly.
Okay, you know what? I think one of the things taking time is the hands-on. All right. So let's just quickly go through them, go through the theory, right? And then the hands-on, you can go to the labs, all right, and execute the labs yourself. Okay. So can we just do that quickly? Is that okay? All right. All right. So I'll just go ahead. So now labels, labels and selectors. Now, practically, this is central. We talked about this briefly. I know either last week or 2 weeks ago or so. This is central to how Kubernetes works when it comes to labels and selectors. That is how it knows what to do, what to target, what to operate on. That is very central to how Kubernetes works. You even need to, as an organization, if you're working in an organization where you guys use Kubernetes, even have an internal label and selector strategy for your Kubernetes cluster. Like, how do you label things, right? Because it's very important to how Kubernetes works. Labels are key value pairs attached to objects, common label keys. You would see this. Let me see. Oh God, I'm tempted to go back to hands-on. Okay, environment labels. So you can label maybe your pods or your services. Now, okay, an example. Last week we talked about services. Okay. Now, somebody asked this question, like, how does a service know which pod to attach itself to? Labels, one word. All right, labels and selectors. So you give something, an object or a resource, a that okay, this is maybe you say the key is that the tier. Okay, so this set of pods, you can say they are front end applications. All right, and then you now create a service that targets that, or the right word will be selects. All right, selectors, that uses selectors to target those pods that are in that tier. All right, so it doesn't matter whether there are 5 pods, there are 50 pods, whether it's just one pod. It doesn't matter at all. As long as they have that label, it's going to target it. You understand? So that is how it works. Even when it comes to creating taints, okay. We've not spoken about taints. It also uses labels. Oh boy. Let me see. So labels are very central, essentially, to how. And then when you're talking about selectors, it's like, okay, all the selectors that match this value, okay, should, this thing that we want to do, whether it's you want to attach a service, whether you want to taint, whether you want to, do whatever, are going to be targeted. All right. Yeah. Let me see. Okay, let me just quickly run these commands so that we can see. Phew, time flies. God. Okay. Anyway, let's copy and paste. So what we are doing now is that, okay, we're creating pod that we're calling Nginx prod, right? Prod for production. Nginx image. So now we're giving it labels. So we're saying the environment and production, app Nginx, tier front end. This makes sense, doesn't it? All right. So let's run another one. Let's create another. Uh, so this one is for staging environment. So the environment is staging, and then we have a third one for. We have a third one for development environment. Okay. So now let's get. So let's get. Normally, if I do. So let me just quickly do. Okay, get pods. All right, now see all the pods that we've gotten. So Nginx prod, Nginx stage, Nginx this thing. Now let's do this. So let's get pods that have labels of environment equals to production. Now you see, we're able to target, we're able to get that. Same thing we can do. We can do for so okay, let's get all the ones that have a tier or front end. Okay, all right. So just to show you how, now this is just to even get it. Okay, so you can get I mean, there are different kinds of queries that you can do. All right. I think I'll just have to record a video to send. All right. So I want us to let's do a quiz. Would this be a wise thing to do? I really wanted to touch on this. Kubernetes API thing. Okay, let me just quickly run through this. So now, the Kubernetes API is the central communication hub for the entire Kubernetes cluster. All right, so everything goes through the Kubernetes API. All right, so it's I wish I could go deep into it, but those of you, especially those of you who have the courses, the James Spearing course, it goes really deep into this, and I will encourage you to really pay attention at that point. So Kubernetes has this RESTful API interface. Okay, you can do all that. You can create all these things that we're doing. All this now. The first thing you need to understand is that this thing that you're seeing, this CLI tool, kubectl, is just a wrapper around the Kubernetes API. So what we are doing is that we're sending commands. Okay, so if you do kubectl get pods, right, and then you do I think is it dash v or dash v. Let's just try. 6. Now a this is a get request. You can see this if you understand the HTTP request. This is a get request. Okay, you can see that it's getting a get request to this endpoint. All right, you can see. I mean, this is your normal. I mean, those of you who build applications and things like that, this is very familiar to you. Okay, so that's essentially Kubernetes is just providing APIs, this thing, and you can even get all the APIs, all right, and use it in Postman, all right. But sadly, we can't go into all of that. And then it also has authentication. So the Kubernetes API also handles the authentication. Okay, so when a request comes, it will check, okay, where is this request coming from? Okay, and then he checks the authorization, checks the authentication, checks the authorization, like, okay, do you have access to what you are have authentication to be able to access what you're requesting? Okay, and then you're able to do, if you're able to do, create your normal CRUD operations on the Kubernetes API. So yeah, I will have to do a video to send. Okay, let me rush to RBAC. RBAC is just role-based access control, all right, and security. So the way Kubernetes works, Kubernetes doesn't really handle it doesn't handle users. Okay, it doesn't handle. There are some things that Kubernetes doesn't handle. So it's not like you can go and create a user in Kubernetes. Okay, but you can create like roles. Okay, and attach maybe if it's a service account, you can attach a service account to that role. And then there are different kinds of roles. There are roles, and then there are cluster roles. Okay, just rushing this thing now. Let me check. Is this making sense? What if the selector is supposed to select one service, but you've labeled 2? Sorry, I'm not sure I understand this question, Edosa. What if the selector is supposed to select one service, but you've labeled 2? Yeah, if you, so for instance, let's take a service, all right, and you have 2 pods that you've labeled as front end. That selector, that service, which you now say, okay, you want to, you give it that, okay, the selector is that it will attach itself to anything that has a label of tier front end. Tier equals to front end. All right. What that means is that it's going to attach itself to those 2 pods. Do you understand? It's just going to do that. All right. Okay. Let's see. What else do I want to touch? Yeah. Okay. Let me quickly talk about storage and stateful sets. Now, so when you look at in Kubernetes, most things are stateless, but you need to persist data. Okay, so that's where you use persistent volumes and persistent volume claims. In the video that I'm going to do, I will explain this some more. Um, because I don't want to go deep into this now. Then stateful sets, stateful sets are very similar to deployments. Okay, but the difference, right, is that stateful sets are for deploying applications that need that need to store state. They need to okay, let me give you an example. Tony, you're on point. Yes, databases, for instance, you will use a stateful set. For instance, if you look at a deployment, okay, it's they're kind of ephemeral. So the pods, all of them are using one persistent volume. If you attach a persistent volume, all of them will use one persistent volume. So it doesn't matter. One pod can go down, and it's it doesn't matter. Another pod will come back in its place. It doesn't really matter. Because they're using replica sets. Okay, if you remember how it was explained last week, so you have deployments, and then deployments creates replica sets. Now, remember, the job of the replica set is to ensure that no matter what happens, it maintains the replicas, the number of replicas that are required. All right. But stateful sets, on the other hand, okay, it has this system where it orders, where the pods that are created are ordered. All right. So it could create, let me see if we can quickly run some. Where is that? Let me see if we can quickly check the stateful sets. Yeah, there we go. Okay, so let me clear this. So let's look at this. So kubectl creates, okay. Like I said, stateful sets and deployment are very similar. So what we're doing here now is to just use that trick I talked about to create a file, okay, a YAML file. Then we will now edit that YAML file, the way we want. This trick you need to really know it, because it will help you in your CKA and CKADA. Okay. So if you look at it, we have a file called what? Stateful set. That's what we created here. All right. So we need to, thank God somebody advised me to install Nano, because we would have had an issue here again. So we need to edit this file. All right. So let's see, what is it saying here? So let's modify this to change it to a stateful set. So this is a deployment, but we're going to change it to stateful set. We're going to change it to stateful set. What else are we going to do? We're going to remove some things. We're going to remove these resources. What else? We're going to remove strategy. Yeah. So let's do that. Set. Okay. God, I miss Vim. So change this to service name. And then next. This is just to give it a name, so it's not really. Control X, Y, enter, boom. All right. So now let's apply it. All right, so stateful set created. So let's look at the stateful sets. So let's check the pods. Where is it? Oh, control. Oh. So now I want you to see something. So what is this saying? Say engine X 0 container creating. Now if we check again, all right, but it's only going to create. We remember the replicas we said we wanted 3. It's going to create 3 eventually, okay, but it's going to create them in order. So that's why it's giving it say 0, okay. Let me see. So now you see that one is now running, so it has gone to the next one. Is now creating the next one, engine X1, okay, and then to now create the next one after this one is done. Engine X2, by the time this one starts running, okay, it will do that. Okay. Network policies. Let me just quickly touch this. Network policies. Now, we've created all these pods. Okay. If I go into, let me see. No, let me just use this guy's stuff. Network policies. Awesome. Okay, so we have Nginx prod running. Let me expose prod. Please, all right, so what we've done now is that we've created a service that exposes the Nginx prod, okay, on port 80. Okay, so now I want to so what we're going to do now is that we're going to create another pod, okay, with a curl image. All right, so we can use curl inside of it, okay. And then what we are saying is that we want to start a shell inside, so it will take us, so this will take us into a shell. All these things, this is to remove it once the pod stops running. So it removes once we stop the pod, once we come out of it, it will remove it, and then it gives us an interactive terminal. So that's what this command is doing. Come on. Okay, anyway, while that is happening, let me explain what we're trying to do. Okay, all right, cool. All right, so what we want to do now is we will, Nginx Kubernetes has this internal DNS service going on with it. So I want to curl that Nginx, that product, that Nginx prod, okay, from this pod. I just hope people are following. All right, so let's curl it. So now we can see that we're able to access that pod, this Nginx prod, all right, from another pod. Okay, so what that means is that they are from one pod, you can connect to another pod. All right, now we're doing all these tests and we're playing around. That's okay for now, but however, you don't want a situation where from any pod somebody can access some other pod that they are not supposed to access. All right, I'll give you an example. For instance, you want to ensure that maybe you want to ensure that, okay, maybe your database, your application should be the only pod that is able to access your database. So any other traffic should be blocked. All right, so that's where network policies comes into play. All right, so you can determine, like, you can do a fine grain thing to say, do a fine-grained policy to say that, okay, um, um, traffic can only come from this particular set of pod. And you know how it does that? Can anybody guess? Labels, labels and selectors. All right. So it will say traffic can only come on this particular port to these pods, to this set of pods from this particular set of pods. That's essentially what it is. Okay, so you can specify. So you can specify ingress rules, specify egress rules as well. Okay. Sorry, I'm just rushing so that we can touch on all these things. Then finally, pod disruption budgets. Now, if you remember, last week we talked about replica sets. So let me just check to ensure that people are still here. Yeah, Gustam, I agree with you. Vim is the best. If you recall, last week we talked about replica sets, and we said that replica sets will ensure that a certain number of pods are running. All right, so no matter what, we try to ensure that those number of pods are running. But what happens if we somehow we are draining? Maybe we're trying to update our nodes and our control plane, okay? And somehow we are maybe draining the nodes of all the pods. We are cordoning nodes so that and then draining it. What do you think will happen? Replica sets will not be able to help in those kind of situations because I wish there was time to show you a hands-on of this. That's the best way to explain it. But the major idea, right, is that with pod disruption budget, what it's just saying is that you will set a number of pods. So let's say your number of pods are 25, or let's say 10, for instance, of pods that are running. What this PDB does is that you can now set it to say, no matter what happens, at least 2 must be running. So even if you are going to drain the nodes to say, okay, you want to update your node, all right, and you are draining the nodes, it will not happen because 2 pods must be running. Okay, so it will say it will not succeed, or it will first of all move the pods to another worker node, okay, and ensure that at least 2 are running, and then it will it will allow you continue. I just hope that makes sense. This is already 8:58. All right. Thank you very much. Are there any questions? Oh boy. Hello.
Yeah, we're here. We heard you.
Okay. So yeah. So what do we think? What are there comments, questions?
Excuse me, please. There was a link you dropped last class, so to be able to access the Docker Compose. I don't know if you can drop it again, please.
Okay. I'll do that on the Slack so that it's not
Okay.
like permanent.
Thank you.
I will do that on the Slack. I'll do that on the Slack. Okay. Any other questions? All right. So should we go ahead with the live quiz, or should we since we didn't really go deep? Okay, you know what? Okay, let me get some responses to that question first before I say what I want to say.
Well, me, I'm thinking the quiz. This class now was quite high level. If the quiz is not as how do I put it now? If all of us will not fill the quiz, then let's
Okay,
do.
you know what we can do? Let's do the quiz,
Yep.
but we will not. It's just to practice. Okay, we will not we will not
Ah,
add it. We
that's
will not add it to the leaderboard.
mm,
Okay,
that's
is
a
that
good one.
okay?
That's a good one for learning purposes, which is why we're here
Yeah,
anyways.
but we will not add it to the leaderboard because we were not able to go deep. So even so, what that would mean is that the only people that will be able to actually get some of it right will be people who maybe already have previous uh, knowledge. All right, but maybe let's just do it for learning purposes, and then we so that we learn and we can build the muscles um for it. Make sense?
Makes sense.
All right, nobody else is talking. Um, okay. Boy. Uh, awesome. All right. This is the day we finally beat Gigi. All right. Okay. So please use this link to go and join so that we can start. Don't worry. Let's just when no pressure at all. Let's just use it to. I also want to encourage you to use your full names in this field, please. In this full name, use your actual name so that we can. It's easy to track. So that it's easy to track. Yeah.
Can you drop the pin, please?
Yeah. Just a minute. I'm trying to start it. All right. So the pin is 191098. Uh, some people are fast though. My was already awesome. So let's just have fun with this one. No pressure whatsoever. Yes, so Raman, you can take it. Raman the man. Where is Kami? Not Kami. Kami has entered as not Kami today. Oh my goodness. Okay, so I think that's everyone. Is it? All right. So are we ready to? Should we go? There are 22 people, but I see there are 26 people on the call.
Let's do this.
All right. Is it that some people are saying that since there's no leaderboard, this thing, I know.
I I think you spoiled it. Maybe you shouldn't have even told anyone. Maybe after we had done it, that's when you'd have told them. Okay.
We have people to protest. No.
But it should still be fun. Me, I'm looking forward to it still. Cause
Protest. Oh. Okay. So ready to go.
Mhm.
Okay. Go then. So A team needs to run a database backup every night at midnight. Which Kubernetes resource should they use? Job, status set, daemon set, cron job. Okay,
Okay.
all right. Not coming. Yeah, I also just want to let you guys know that the time that you can get it right, but if you're slow, it will. And I think that's one of the ways that Kami has been using to, because I was checking the. All right. Which of the following is not a valid way to use a config map in a pod? As command line arguments, as environment variables, as a binary executable, as volume mounts. Okay, show results. Interesting. In Kubernetes RBAC, what is the relationship between a role and a role binding? Kami is vexing. All right. All right. This is actually very encouraging. This is very encouraging. When using labels and selectors, which of the following is a valid label key? Hmm, Okay, let's see. Um, Inedosa, okay. All right. What is the primary purpose of a pod disruption budget as a PDB? Rahman, people are cooking. In a stateful set, what ensures stable network identity for pods? Okay, we didn't talk about this. Okay, go. Coming, well done. Which statement about network policies is correct? What is the difference between a config map and a secret? Oh my god. Which feature ensures that pods in a stateful set are created and terminated in a specific order? All right, finally. When using jobs, what does the back off limits parameter specify? Okay, well done, everyone. All right. Let's see. Okay, very encouraging results, really, um, especially for a situation where we didn't get to go deep as much as we wanted to. But well done, everyone. Not Kami, well done. Raman Diman, well done. E Nedosa, well done. Today I make first five. Who's that? Destiny. Destiny, which one is your name here? Are you Caesar? Caesar's age. I think Necrospeed also comes to play. All right, well done. Okay, so in Edosa, that's Iliano. I hope I'm not such a tush name that I don't even know how to. Blessing in yellow, I was logged out. Oh, sorry, man. I'm really sorry about I know some people reach out to say that they get logged out or things like this. I'm really sorry. There's hardly anything I can do. Think about it. If out of 26 people, maybe two or three get logged out, have network issue. I can't. There's hardly anything I can do because it's not the majority. All right. So please just try to understand. And yeah. Okay. I think we're good for today. Yeah, I think we're good for today. Well done, everyone. I just want to see. So yeah, not Kami, Raman Diman. Well, this is not ordered according to rank, but yeah, well done, everyone. Um, enjoy the rest of your evening. Are there any questions, any final statements that anybody wants to make before we close? Okay, no one. All right. Thank you very much, and good night.